Good morning, students. Lastly, we can see in the unit number 2, avalanche effect with examples. We can see a few encryption, decryption standard, DS algorithm, its key size, its strength, and the few features of encryption and decryptions. Now we are start with the unit number 3. Chapter 3 is called the conventional encryption techniques. There are outlines are the highlighted points are the multiple encryption, that means double DES, triple DES, modes of operation, in which we can cover electronic code book, cipher block chaining mode, cipher feedback mode, output feedback mode, and counter mode. The modes of operation: if message is longer than block size. Block size is a predefined value to store a particular information in particular block. This is the smallest amount of the memory part of data structure. Then block cipher can be used in a variety of ways to encrypt the plain text. Soon after, DES was made a US federal standards, another US standard appearing given for recommended way of using DES for data encryption. This mode of operation have since been standardized internationally and can be used with any block cipher. Type of modes of operation. We can see the mode of operations are electronic code book, cipher block chaining, cipher feedback, output feedback, and counter. Mainly use the counter for count a few numbers and iterations or the process or the execution cycles. ECB mode, ECB, that means electronic code book, is the simplest mode because it's the approach to using a block cipher. Each block of 64-bit, this is repeat. We are also studying in unit number 2 in DES algorithm. We can see 64-bit in which maybe you remember 8-bit considered as a parity bit and it's handled independently. It is like a code book, use lookup. The same 64-bit block has the same ciphertext, same key is used in all block encryption. The applications are secure transmission of key. ECB, continue. Plain text M is divided into T blocks of n bits, M1, M2 to MT. The last block is padded if necessary. The ciphertext blocks are C1 to CT are defined as follow. Equation Ci is equal to Ek under bracket Mi. Not that if Mi is equal to Mj, then we have Ci is equal to Cj. Thus, pattern in plain text reappear in ciphertext. This is a figure. We can see the ECB, the plain text divided into blocks. Block 1 to 5, block encryption process. Each block we follow the equation we are seen in last presentation, last slide, then converted in ciphertext. Same as you can get as output in particular block, the paid last block if necessary. ECB scheme. Here you can see the encryption and decryptions of particular plain text. We can use the secret key, decryptions, and ciphertext block. Here we are declared as a E, PI, K, D, and CI. You can get n bits in decrypted form after applying the particular equations as seen in last slide. ECB mode, the encryptions, key K, plain text, P is equal to P1, P2, to Pn minus 1 to Pn. Ciphertext, C is equal to C1, C2 to Cn. The equation is Ci is equal to Ek under bracket Pi, P for plain text, comma 1 less than is equal to I less than is equal to N. Then For decryptions, key K, ciphertext C is equal to C1 to Cn, plaintext P1, P2 to Pn minus 1 and Pn. Here, the equation for decryption is Pi is equal to dk under bracket Ci, comma 1, the value of 1 less than is equal to I, and I less than is equal to n. Break the message into 64-bit blocks, padding the last one, and encrypt each block with a secret key. The two major problems occur during this process in ECB mode. The first one is two identical plaintext blocks produce two identical cipher blocks. Second one is block can be rearranged or modified. It is a problem. The properties of ECB is simple and efficient. The parallel implementation is possible. Does not cancel plaintext patterns. Its active attack are possible in ECB mode because plaintext can be easily manipulated by removing, repeating, or interchanging of block. Advantage and limitations of ECB. Repetitions in message generate the same ciphertext. For example, particularly with data such as a graphic. Main use is sending a few blocks of data. Here our next topic and one more important question is also many times asked in GTU examination, the why cipher blockchaining, why we use CBC. It's used to solve security deficiencies in ECB. It's a 3 marks question, repeated, same plaintext, block result, different ciphertext blocks. Two identical plain message produce two different cipher messages. Message is broken into blocks, but these are linked together in the encryption operation. Each previous cipher block is chained with current plaintext block. Hence, name use initial vector IV to start a process. To start a process, we can use initial vector. The applications of CBC is used for bulk data encryption and for authentication. CBC mode, the goal is the same plaintext block is encrypted into different ciphertext block. Initial vector IV, same 64-bit long and is a fix. Here we are using this word fixed because no alteration or manipulation in blocks are possible. Is padded plaintext P dash is equal to P1, P2 to Pn. Here shown the figure CBC, the plaintext first is a random. We can use XOR operations to manipulate or update a particular bit sequence which are stored in particular block 1 to n. And then random block, the block are encrypted in particular form as per desired outcome. Then same output which are stored in block 2, 3, 4 and 5. Here one block is used as a padding. Paid last block if necessary. Remember this thing, paid last block if necessary. Random block called IV, initial vector, can be sent in plaintext, not a secret, just prevent a code boot. Often times a timestamp. This is a time-bounded activities and counter is used to calculate the timestamp. So here we are use this word. This text is also important, not a secret. Just prevent a code book and oftenly, repeatedly, it's used a timestamps. CBC schemes. Here you can see in figure. Here we see in the encryption and decryptions equations are initial vector are there C0 Ci, Same as above chapter, we can also see these kind of equations in conventional encryption method and DES algorithm. CBC mode, once again, same equations, this is repeat. Now, advantages and limitations of CBC. Each ciphertext block depends on all message blocks. Remember, each ciphertext block depends on all message blocks. So, the change in the message affects all ciphertext block after the change as well as the original block. The need of initial value known to sender and receiver. However, if initial value is sent in clear, an attacker can change bit of the first block and change initial value to compensate. Hence, either initial value must be fixed value or it must be sent encrypted in ECB mode before rest of message. Now CFB mode, cipher feedback. We are continue in next sessions. Thank you.